number 2. Again, I have a capacitor of capacitance C attached to a battery of potential difference V.
Yes, sir.
Okay. Now, I am going for no detaching of the battery. Okay. I will just pull the plates of the capacitor away. Okay. So this capacitor will have a charge Q. I'm not detaching back.
Wouldn't it be same as the previous thing?
Last time we did not have battery.
But still we had potential difference.
Potential difference is fine. You said won't it be same? How will it be same? Last time we did not have battery.
I mean that was
We
fully
have.
charged, so it will act as the same thing.
That's why we are doing this case to know the difference, right?
Yes, sir.
Will it act as the same thing? If it will act as the same thing, what was last thing's condition? Charge is same. Charges can't flow. Why? Because there is no path for charges to flow. Here, is there a path for charges to flow?
Yes, sir, there is. Okay.
The last case and this case can't be same.
Over here, Q is not constant.
Here, V is constant. Okay? Because battery, how much ever potential difference it is giving, is not in our hands. Battery will do its own job. Now, initial distance between the plates is D, final distance is D1. Okay?
Yes, sir.
Now, the potential energy initial is half CV square. Correct?
Yes, sir.
See, here V is a constant, capacitance is a variable. So, C initial I am writing.
Yes,
Ci.
sir.
Okay. Let the area of the plate be A. My capacitance initial will be what? Initial capacitance is epsilon naught A by D. Correct?
Yes, sir.
So my initial potential energy is half epsilon naught A by D
V square.
V square. Is this clear?
Yes, sir.
Now, here if I want to talk of force, can I write it as minus du by dr?
Yes, sir. It will be half epsilon naught A upon D square. Into
Remember, in energy story, I always told you, I can write F is equal to minus du by dr only when my work is minus du.
splits are same.
Here, battery is also there in the story.
Well, basically over here only we are taking delta V is, as initial minus final.
I am asking something.
Yes.
I am saying F is equal to minus du by dr. I can write only when my W is minus du, right?
Yes, sir.
Is W minus du over here, work done, is it change in potential energy of the capacitor?
Yes, sir.
Good. Then I am saying, then what is this battery fellow doing? You have work done by the external force, you have work done by battery, and you have potential energy of capacitor. 3 things are there, not 2 things. Work done cannot be equal to minus du. Work done by the force cannot be equal to minus.
Here it should be work done by battery plus work done by capacitor.
Correct. Correct. If it is work done by battery and work done by the external force, then I should have force by battery and force by external. But practically, there is no thing force by battery. Battery is not physically
Oh,
pulling it, it is
okay,
just
yeah,
giving
yes,
energy.
sir.
I have battery in Pakistan, I have my circuit in.
No, force only. Yes,
Okay.
sir.
Battery can be somewhere else, it will not have physical force acting on it. That means I can't write this as what I am saying.
Yes,
We are
sir.
only sharpening our physics concepts more and more. Wherever I see potential energy, I want to write. Wherever I see U, I want to write F is equal to minus du by d. Is not right. Is this clear? Oh, earlier I wrote U something something. Why not write F is equal to? Think about if I can write it or not to go in a particular fashion. Detail.
No, sir.
Right? Clear? Next. My final capacitance is epsilon naught A by E1.
B1
Right?
into V square.
Yeah. So, final potential energy is what? Half epsilon
Half epsilon naught A
by
upon D
D1.
into V square. Yeah, D1.
So,
Yes.
just for the change in potential energy of my capacitor is final minus initial is nothing but how much will I get? These are
Sir,
all
1 by,
constants.
yeah,
Epsilon naught A V square by 2 are all constants. 1 by
into
D1
1 by D1 plus 1 by
minus
D.
1 by D.
Sorry.
Minus 1 by
Yes,
D.
sir.
Okay,
By
great.
taking final minus initial. I mean,
Hmm?
fine, sir. Okay.
Change in physics is always final minus initial.
Yes, sir. That is fine.
Okay, I am just interested in some more things of this story. My battery potential difference is constant, but my charge is not necessarily constant. Now it is a closed circuit, therefore my charges can flow.
Yes, sir.
My Q initial is equal to C initial into potential V.
Mm-hmm.
Correct? My Q final is equal to C final.
P final into potential.
What is capacitance initially? Epsilon naught A by D. Epsilon naught AV by D is my initial charge.
Yes,
My
sir.
final charge on the capacitor is epsilon naught
Epsilon naught
AV by
AV
D1.
by D1.
D1 in our case is greater than D, correct?
Yes, sir.
In our case, we said we are pulling, we can also push closer. Okay, that also we can. D1 is greater than D. So my final charge, is it greater than or lesser than initial?
It is lesser than.
Because inversely proportional. So QF is less than Q initial. Correct?
Yes, sir.
Oh God, I'm getting more and more information. That means initially charge was more on capacitor, and finally the charge is less on capacitor.
Like charges are going back to the conductor.
Charges are going back to the conductor. That
Means
means
potential over there is more. Uh,
ideally, if I say my battery, this is positive terminal, this is negative terminal, and if I say my charges are flowing like this, now charges are going back. That means, can I say that my
potential difference is less now.
current is in the reverse direction?
Yes, sir. It means that potential over there is like less. Potential difference.
Potential difference over there is a
I mean, it will go from high potential to low potential. So it will be low potential there.
a high potential to low potential. Therefore, are my charges going due to high potential to low potential, or is Hitler letting them just knock them back and push them away? I will come to your point very clearly. You should know, whenever charges are flowing, higher potential to lower potential only charges will flow. Okay, that is fine. Now let me come to your point that you wanted. This is 1, this is 2, this is 3, this is 4. Correct?
Yes, sir.
You are saying my charges are coming back to the conductor. That means V4 is greater than V1.
Yes, sir.
And V3 is greater than V2.
Yes, sir.
Should it imply that my delta V across capacitor is different from delta V across battery?
Delta V is same everywhere. I mean across
Delta
the
V's are same. Okay. That means this is my battery, this is my capacitor. I have minus 10, minus plus 10, let's say, or if you want take this, that's not the difference is 20, right?
yes.
So you are saying here I have something like minus 5 and plus 15. Maintaining difference is 20 on both, but you are saying 1 and 4 are different potentials. This and this is different potential, this and this is different potential, is what you are saying.
Yes, sir.
Yeah. Okay. So if I have plus 15 and plus 10, my positive charges are coming from there to here.
Yes, sir.
And minus 5 is also greater than minus 10. So my positive charge actually should go down. My negative charge is basically coming here.
That is minus 5 is high and low, sir.
Minus 5 is greater than minus 10.
It should go down only.
This is higher, this is lower. Positive charge will go from higher to lower.
Yes, sir.
Positive charge will go from higher to lower.
Okay, yeah, yes, sir.
The negative charge will go from lower to higher.
Yes, sir.
So here my positive charges are coming like this. Correct? Positive charges are coming like this.
Yes, sir.
And my negative charges are getting deposited on the plates.
Yes, sir. It will be the same thing again.
It will be the same thing again. Okay. Very, very great and amazing. Now let us come back to what we are trying to discuss. We are trying to discuss that my charge final on the capacitor is less than the charge initial on the capacitor. That means the charges stored on the capacitor plates have gone back into the conductor. Is our observation correct?
Yes, sir.
Now you said V1, V4 are not same, V2, V3 are not same. That's why the charges are flowing. So I gave numbers over here to thoroughly understand. You said the potential difference has to be same. So I said, okay, let's keep 20, 20. Numbers here and there are different. Okay. According to our example, my positive charges are going from higher potential. So, okay, my positive charges are going from higher potential to lower potential. Great. But the same example, if I have to maintain the potential difference to be same, then my negative charges are going like this. That means more number of negative charges are going like this. That means, understood? The negative
Yes.
charges are going on the plates of the capacitor while the positive charges are coming away from the plates of the capacitor. That means my
Yes.
charge on one plate is plus 10 and my charge on another plate is minus 50. Is this capacitor possible?
No, sir. There should be equal number of charges of positive and negative.
So my point here, you suddenly came to a state situation. Yes, the final charge on the capacitor is less than the initial charge. So the statement that you mentioned that the charges have restored back into the conductor It's fine, correct. Immediately you add it because of the potential differences to be different. Arey Baba, V is constant, battery is the BAP. He is only giving potential difference. Because of battery's potential difference only, V4 minus V3 potential difference is being maintained. How can you say when because of battery only that thing is happening, how can you say suddenly V1 and V4 are different? Why is V3 minus V4 same as 20 volts? Because of battery connection only.
Yes, sir.
Now this fellow, let us say, is minus 10. Battery itself is giving the potential difference over there. So if this is minus 10, it will ensure that is also minus 10.
Yes, sir.
Because of that process only, potential difference 20, potential difference 20 is maintained. The process through which the potential difference is maintained, how I am minus 10, I will make him minus 10. I am plus 10, I will make him plus 10. Therefore, 20 is same.
Yes, sir.
Because of battery only, potential difference across capacitor is constant. How can my 1, 2, 3 force be any different? The charges are being sent back to the conductor not because of high to low it has to go. Not always that is the story. Sometimes Hitler will come and he will physically make it go away irrespective of high to low.
Yes, sir.
And another point, if it is going high to low, it should be an automatic process. It should happen automatically. I don't have to externally do anything to make that happen. But here I am pulling the plates away from each other, right, externally.
Yes, sir.
That means it is not an automated process. It is happening unautomated process, or it is happening by an external,
Yes, sir.
right? So that high potential, low potential is not applicable over. Anyways, the charges on the capacitor finally is less than the charges on the capacitor. Really? That means there is some kind of a charge loss in charge, right? Loss in charge.
Sir, then what is the reason for it, like,
To flow,
reduce the number of charges in the camera?
to reduce the number of charges. Capacitor, what?
We can tell it is a closed one, but then why should it go?
So what happened is I have eaten 100 laddus and I am sitting in a relaxed way. Now you came and sat on my stomach. My charges will come out because you're externally pulling the plates of the.
Yes, sir.
My charges will come out. This is different, and if I eat 1000 laddus, it will automatically come. That is a different situation.
Yes, sir.
I ate 100 laddus. Okay, my stomach is full, I agree. But it's not an automatic process to come out. You coming and sitting on it will make it come out easy. It will make it come out.
Yes,
Similarly, me holding the plates of the capacitor and pulling them away from each other is making the charges to reduce because it is varying the capacitance. Because the plates can't hold any charges equivalent to whatever are there. Because the capacitance is changing, so therefore my charges on the plates are also changing
yes, sir.
to maintain the potential difference to be constant. My potential difference has to be constant because my battery is still attached, but my Q is equal to CV. As I am varying capacitance, my charges on the plates are varying. Why is it so? To maintain the potential. To maintain potential difference constant according to the requirement, charge increase or charge decrease is going to happen.
Yes, sir.
Okay.
Yes, sir.
Any doubts?
No, sir.
we are not able to fit in our high potential, low potential story over here because it has nothing to do over here. Also, positive charge will go from higher potential to lower potential is a natural process. Here, story itself is not natural. Some external agent is doing something to achieve something. So it is not a natural process. Therefore, our high potential, low potential story, therefore, will not adjust over here.
Yes, sir.
What is the loss in charge in the capacitor, on the plates of the capacitor? My initial charge minus final charge, right? See, I don't
Yes,
have
sir.
any change in physics should be final minus initial stories over here because I know initially there were 100 laddus, now there are 30 laddus. How much is the loss? 100 minus 30. Initial charge minus final charge because initial is greater than final. That's why directly we are writing. So if you substitute, what will you get? All these are constants. 1 by d minus 1 by d1. Correct?
Yes, sir.
This is the loss in charge. Okay.
Yes, sir.
Can I say that this much amount of charge, let me call this as delta Q. Can I say that this much amount of charge has flown through the circuit, closed circuit?
Yes, sir.
Why now I'm corrupting you by saying this closed circuit? See, that's the thing, right? You should identify as soon as one new word comes, some new story is coming, trying to fit in one bolt at a time. I am saying where are these charges going? These positive charges are going back to the conductor, negative charges
They
are going.
flow through it continuously.
Correct. Going through it continuously. 70 laddus went back, correct?
Yes, sir.
Can I say my negative charge over here? Is it possible for my negative charge to come and sit over here, or should it sit only over here? You decide. It can come or it can all girls should sit here, all boys should sit here.
Sir, it is a
Positive
closed
charges.
circuit, so it will
School
flow.
teacher is a transgender voltage. So it is maintaining all boys sit here, all girls, all positive charges come here, all negative charges come here. Why I am
Sir,
trying to corrupt
it
you?
is a closed circuit, so definitely it will.
Correct? That's why I am trying to corrupt you is initially I told the story that way for your better understanding. But like I said in 2, 3 classes before also, as soon as we say charge is flowing through the circuit. Right? So charge flow is nothing but my current only. If my positive charges are coming back like this, I will show that the current is flowing like this. Is this clear?
Yes, sir.
Whenever a delta Q charge, now this statement is important, focus. Whenever my delta Q charge is flowing through a potential difference V of the battery, I'm not concerned about capacitor. My loss in charge is delta Q, right? And this delta Q charge is flowing through the circuit, right? And in the
Yes.
circuit, I have a battery, right? So this delta Q charge is flowing through the battery of the potential difference delta V, right? Or potential difference.
Yes, sir.
My charge is flowing through the battery, so I can say my work done by the battery is equal to delta Q into V.
Yes, sir.
This, you're making your notes, you make a note of this. If my 70 laddus pass through a potential difference of V, irrespective of which school I am in, doesn't matter. Work done by that battery is 70 into V. If my charge is
Should I note
flowing
it
through a
down?
battery and there are 20 charges flowing through the battery and the battery's potential difference is V, the work is done by the battery. 20.
Yes, sir.
Remember this, okay? We will discuss it. We'll see. Okay. Right now, what
Yes.
I am saying, work done by the battery is my delta Q, which is the charge that is flowing through the circuit into the potential by the battery. Is this clear? Simply
Yes, sir. That
substitution.
is what we did in the last class.
This is what we did in.
I mean, we just did like the flow of charges into the potential difference. Like now, delta Q is
I
flowing.
know,
So
yeah. So I'm just substituting, okay?
Yes.
Epsilon naught A V square will come, right? This here, I'm multiplying V square, okay?
Yes, sir.
1 by D minus 1 by D1. Clear?
Yes, sir.
Oh, so my work done by battery is basically twice of my change in potential energy of the capacitor, right?
Yes, sir.
Or if I want to find, here we said there are three things involved: force is involved, battery is involved, and potential energy of capacitor is also involved. Then you said by yourself, can say what total work done is that, if you remember, right?
Yes,
So
sir.
using that logic, the work done by my force fellow is my change in potential energy.
Of the capacitor plus change in potential energy of the
Is it
battery. It
so?
here we can directly write in terms of work done.
So let us, yeah, we can write that. See, let us just take a look. Okay, my initial potential energy is less, or final potential, which is greater than, which is less than? We didn't write that. Initial is epsilon naught A by D. Everything else is the same, right? Final is epsilon naught A by D1. D1 is greater than D, right?
Initial is more than final.
D1 is greater than D. That means this fellow will be less than that fellow. So initial is greater than final, right?
Yes,
Okay,
sir.
fine. My initial potential energy of the capacitor is greater than the final potential energy of the capacitor. Okay.
Yes.
So
sir.
this change in potential energy, that means, is the capacitor giving laddus or taking laddus?
It's taking
Okay, fine. It's taking.
energy lost.
Energy is lost by whom? Capacitor.
Yes, sir.
So is capacitor giving laddus or taking laddus?
It's giving.
Giving away, right? Capacitor is giving away the energy.
Yes, sir.
Capacitor is giving away the energy, and let us say the energy that it gave is some X.
Yes, sir.
Now, how much battery work done across the battery is what? 2x.
Yes, sir.
So, capacitor gave how much? Is this correct?
Yes, sir.
If this fellow is x,
Mm.
I'll multiply this by 2, I'll get this. And it will be 2x. Is this clear?
Yes, sir.
Why I'm writing in terms of this? It will be easy to understand.
Yes, sir.
If this term is x, this term is 2x.
Yes, sir.
Capacitor is giving x to battery. Capacitor
Giving.
is giving x to battery. Yeah, you have any doubt?
No, sir.
You should, because I just corrupted you.
Exactly.
You should ask them. You are see, that's exactly what I'm saying. But I'll conclude that explanation later.
That's why I waited. So
Capa-
like you.
Capacitor gave x. We
Yes,
only
sir.
know that. To whom we don't know. Okay? Capacitor gave x. Initial is greater than final. That means it lost its energy. Right?
Yes, sir.
Initial energy of capacitor is greater than final. That means it gave its energy. So capacitor gave X is known, to whom we don't know.
Yes, sir.
Second thing, this work done by force, is someone pulling it, or it is just a invisible thing? I mean, while
It isn't invisible.
huh?
It isn't invisible, sir.
Right, somebody is really pulling it. If somebody is actually struggling and pulling it, work done by F is on the system or by the system? By F, that force F, is he working on the system or is the system working on him?
He's working on the system.
Right, I want to lift this. Am I giving it energy or is it giving me energy?
You are giving it energy.
So I am holding the plates of the capacitor and Hulk. Ah! Am I losing energy or am I gaining energy?
The external agent will lose energy.
Until unless it is Hulk, right? So the external energy, external fellow is also giving something.
Yes, sir. Okay.
Now I have only two people over here. And I have capacitor, other I have external. Who is left? The other fellow who is left is battery.
It can give to capacitor also.
How many characters are there in my movie? 3 characters. One fellow is capacitor, one fellow is external agent, other fellow is battery. That's what we wrote here, right? External
Yes, sir.
agent, battery, capacitor. Capacitor gave some laddus. Okay, to whom? I don't know. External agent, is he giving or is he taking? He is giving. That clear?
Yes, sir.
Is clear. Capacitor is giving, external agent is giving. Who is the third fellow remaining in my story? Battery.
With respect to that battery only, sir. But
These
then,
two fellows are giving to the battery. And of course, battery fellow is saying, I want 2x.
but then how do you know it will give X only?
You're absolutely right. So I gave 50 laddus. You have 100 laddus. So how many extra laddus did you get?
What? Sir, yeah, 50 only.
Capacitor gave
I
how
already
much?
have 100, sir. Then I'll get extra 50 only.
Capacitor gave how much? X. Now battery is saying I have 2x. Somebody gave me 2x.
With respect to that, it should be X only.
Wait, what? No, you are not following. I am saying there are only 3 people in the story. Capacitor gave, external agent also gave. That is clear, right?
Yes, sir.
Capacitor is giving, external agent is giving. Who is the third fellow? Battery, right? So battery
Yes.
is receiving. Capacitor gave how much? X. Battery receiving how much? 2x.
But how do you know battery is giving energy or taking energy?
That I don't know. You are right. You are absolutely right. I haven't yet proved if battery is giving energy or taking
Then
energy.
how can you write like that, sir?
Correct, I know. I'm coming there. I'm coming there.
Yes, sir.
Right? So did battery give energy or take energy? I have to know. So repeat. Capacitor gave. External agent gave. To whom?
Only the third person.
So we are in a courtroom.
Sir, but there is a chance that the external agent can give that energy to the capacitor also.
External agent can give it to the capacitor. Correct?
Yes, sir.
Fine, okay, no problem. But slow. I'm not fast.
Okay.
External agent is giving to the capacitor. So capacitor's energy should increase.
Yes, sir. But it
Capacitors.
is decreasing.
So capacitor is giving.
Uh,
External is giving, but to whom we don't know. Even capacitor is giving to whom we don't know. Is
yes,
external
sir.
giving to capacitor?
It can't be possible because there should
Is
be.
capacitor giving to external?
No,
Hulk.
sir.
In case of Hulk,
That is
right?
also losing energy. What?
Obviously. In case of Hulk, it's possible, but if I am pulling and I am saying I'm getting stronger, I'm Hulk.
Yes, sir.
So, okay, all those things are clear. So, now let me again repeat this way. Capacitor is giving, external agent giving.
Yes, sir.
So, in the courtroom, sir, there is a builder, there is a politician, and there is a businessman. Builder gave money to whom? Don't know. Businessman gave money to whom? Don't know.
They're all three individual people.
There is a politician, there is a businessman, and there is a builder. Businessman lost money, I don't know to whom. Builder lost money, I don't know to whom. The third fellow in the story is politician. Politician says, no, 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 I haven't taken. I didn't take anybody's money. Builder is saying I lost money. Businessman is saying I lost money. Judge is confused. The only third fellow in this story is politician.
Maybe it is 1 second. There might be like energy losing as heat energy. That also might be there.
So there is a chance that businessman went to his bank, sat in the manager's computer, deleted the numbers. System error came. You are saying capacitor basically ate its own energy and it is like I have 100 laddus but don't show anyone, eat 50. I have 50 laddus, reduce. Where is the other? Maybe he burnt his own money. Dear Sherlock Holmes, why do Sherlock Holmes when I am already Sherlock Holmes? Businessman lost money, builder lost money. Third fellow only in the story is politician. So they both gave money to the politician.
That is fine, sir.
There's no other. Builder burnt his own money, businessman burnt his own money. Builder and businessman together they gave each other. But still there is loss of money. Someone else has taken it. I had 100
Sir,
crores.
how do you prove that the third person is
Correct.
taking that?
Innocent, right? Third person has to be innocent. How can a politician be wrong? I agree. So businessman had 100 crores. Builder also had 100 crores. Finally, businessman has 1 crore. Builder also has 1 crore. Where did the 198 crores go away? I have to think. But maybe businessman gave to builder, builder gave to businessman. But eventually, total they have 2 crores only left. Where is the 198? No, sir, I still, even though the story is obvious, I still want to do some Sherlock Holmes here. Something else has happened. Maybe the car driver for both businessman and builder are the same person. He stole it. He's not there in the movie. Don't create fictitious characters. Coming back, capacitor lost energy, gave to someone, God knows who. External agent lost energy, gave it to someone, don't know who. So he gave. Who is the third person? Battery. So capacitor and external agent both have given to battery. Okay.
Sir, but battery, how do you
Politician is
batteries?
already rich, sir. Why will he take any more paisa? He's already rich.
No,
Battery
there's
already is
chance
battery, sir.
that
How
that
can he take
battery
energy?
also
He should give energy.
sir, there is chance that battery can also lose energy, right?
Battery can, sorry, what? Battery can.
Like if battery is getting twice amount of the total energy, then
Anyways, let
would
me
there be
finish up.
change?
Wait. Let me finish off my story, then we will enter into. So capacitor gave, external agent gave. The third person only available here is battery. And capacitor gave to battery X, that we found out because capacitor lost X. Now battery received how much? 2x. Okay. Battery overall received 2x. Clear?
Yes, sir.
So what we are saying, that means the external agent also gave the same amount of energy, that is X. Okay.
Yes, sir.
So work done by the force is same as the X only, which is basically epsilon naught a v square by 2 into 1 by d1 minus 1 by d. Clear? Okay.
Yes.
A capacitor gave X, external agent gave X to the battery. Battery received how much? 2x. Okay.
Yes, sir.
Battery received 2x. So external agent gave X and capacitor also gave X. Hi guys. I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.